The topic of shapes relating to area and volume are quite a pivotal part of the National 5 curriculum, and quite typically they're involved in the exam in a variety of ways. Now we've got a classic example of one here, where it's got a shape represented in 3 dimensions, gives you some information, and it wants you to calculate a few characteristics of it. So what this question says is we've got a traffic bollard, it's in the shape of a cylinder with a hemisphere on top. We're told the diameter and the height. What we have to do is calculate the volume of the bollard, giving your answer correct to 3 significant figures. So this actually brings in a couple of different topics. The first one it brings in is composite volumes, because we've got a cylinder and a hemisphere together, so we need to figure out how to split that and how to answer the question. The second part is the rounding. It wants it to 3 significant figures, so we have to make sure we can recall what the significant figures parts are. Now, the first thing we should really try and remember is what our 2 volume formulae are. So the volume of a cylinder, we should remember that the volume of a cylinder is pi r squared h. And the volume of a hemisphere is just half of the volume of a sphere. So it's a half times the volume of a sphere, which is given by 4/3 pi r cubed. Now for both of these, I need a couple of key things. For the volume of the hemisphere, I simply need the radius of the hemisphere itself. For the volume of the cylinder, I need the radius and I need the height of the cylinder. Now looking at these shapes, we know that with the hemisphere sitting on top, it sits perfectly on top of the cylinder. So the radius of the hemisphere is equal to the radius of the cylinder. We know the diameter of the cylinder is 24. So centre to the edge, i.e. the radius, that's going to tell me that the radius is equal to 12. So we know the r in both of our formulae. What we now need to do is figure out the height, or the h, in the cylinder formula. Now, we are told that the height of the bollard from there to there is 70 centimetres. Now, you might look at that and think, great, we've got the height of the cylinder. But remember that that isn't just the height of the cylinder. If we look at this side on in terms of a 2-dimensional shape, what that is that's the height of the cylinder and the hemisphere together. So it's the height of the entire thing. So you imagine that there's my hemisphere top there. So it's the height of the entire object is 70 centimetres. What we want is this, the height of the cylinder here. Now we need to figure out how to get that. Well, if we look at the hemisphere here, we know that from there to there is the equivalent of the radius of the hemisphere. So what we know is that that there is equal to 12. So this here, if I label that as x, I know then that my height, x, is going to be given by the total height, take away that little bit, so take away the 12. So I then know that my height of my cylinder is going to be 58 centimetres. So now I have all the information, I can just plug the formula in, and I know then that for my total, I add them. So I know at this point that my total volume is going to be equal to the volume of the hemisphere, so a half times 4/3 times pi r cubed, but in this case the r is the 12, so it's times pi times 12 cubed. We then add on the volume of the cone, which is given by pi r squared, so in this case pi times 12 squared times the newly calculated height of my cylinder, which is 58 centimetres. Now the beauty of this one, it's a calculator paper. So you can either do the volume of each separately on its own and then add it, or stick the entire thing in a calculator and do it one go. When you do that, what you'll end up getting is 29,857. Now, there's 2 things we have to remember here. The first thing is it wants a set rounding. So that's the first thing we have to be able to do. So what we then say is fine, we'll take that into account, and we'll say our total volume is equal to this, rounded to 3 significant figures. That gives me 29,900. The other thing that we also have to make sure, and this is for any volume, area, speed, distance, time question, anything like that, is that we have to include units. If you don't include units in these sorts of questions, you'll cost yourself marks because you've not shown that you've fully understood that converting from length to a volume, there is also a conversion of units. Now the easy way to remember it is that length is always centimetres, metres, there's no power. Area is always squared centimetres, squared metres, squared millimetres, so it's always a power of the 2. And volume is always cubic centimetres, cubic metres, things like that, which we can convert into litres and millilitres later if we need to. So I've got centimetres, the lengths of all my sides. So for this one, the total volume is 29,900 cubic centimetres. And that there's our final answer. Again, we've looked and we've communicated it the correct way. It wanted it as 3 significant figures, wanted it as a volume. We've given it to 3 significant figures and we've made sure they know it's a volume because of the units. Remember those key points. Those are key things that we have to be able to do that actually they'll cost you silly marks in an exam, and it's the last thing we want. We don't want to lose silly marks because we've not rounded correctly or we've not included a set of units for a question. Bear that in mind when you're doing these sorts of things.